Hey Fast Track, in today's video I'm going to be teaching you about special right triangles. So there are two special right triangles. They are the 30, 60, 90 and then the 45, 45, 90. So let's talk about the 30, 60, 90. So the 30, 60, 90 triangle has special relationships with the angles and the sides. So we're going to be using these properties and relationships to help us find missing sides for these right triangles. And of course, since it's a right triangle, you can use SOHCAHTOA. But these properties for special right triangles will help you save time, especially on tests like SAT and ACT. Okay, so here's what you have to know. So the side across the 30-degree angle, you label that X. The side across the 60-degree angle, you label that X times the square root of 3. And the hypotenuse, or in other words, the side across the 90-degree angle, you label that 2X. So the proportion for a 30, 60, 90-degree triangle, or the relationship between the sides, is X root 3, and 2X. So this is something I would suggest that you memorize. So let's use that to solve the following problem. So we're going to find the value of X and the Y. So first thing you have to do is identify what type of triangle you have. And of course, you have a 30, 60, 90. And here's how I got that. This is obviously a 90. This is a 60. So of course, our missing angle will be 30 because the three angles in a triangle add up to 180 degrees. Now that you know you have a 30, 60, 90 degree triangle, let's label the sides. So again, the side across from the 30-degree angle should be labeled X. The side across the 60-degree angle should be labeled X root 3. And the side across the 90-degree angle should be labeled 2X. Now remember, the goal for our problem is to solve for the value of X and the Y. So just by the way we labeled it, notice that we already have the value of X. So the X in our problem is 8. Now, let's plug that X in to find the following X and Y value. So to get this X value, you plug in the 8 and you get 8 root 3. Now to get the Y value, you plug in the X right here and you get 16. So the X value is 8 root 3 and the Y value is 16. And again, you could have solved this problem using SOHCAHTOA, but the properties of special right triangles makes it so much easier. As you can see, we didn't do too much work. For example 2, same thing, find the value of X and Y. So first, identify that you have a 30, 60, 90. So that's 60 degrees, this is 90, so this has to be 30 degrees. Now let's label our sides. So the side across the 30-degree angle, you label that X. The side across the 60-degree angle, you label X root 3. And the side across the 90-degree angle, you label that 2X. Now, we have to find the value of X first. So this right here is going to help us solve the value of X. So the side across the 60-degree angle is 12. And you already know that that side should be X square root of 3. So help me solve for the value of X. Divide both sides by root 3. So X equals 12 over root 3. And again, we're not done here because we have to rationalize. We cannot have a square root in the denominator. Multiply both numerator and denominator by square root of 3. And you get 12 root 3 over 3. And of course, we have to simplify. 12 divided by 3 is 4. So our X value is 4 root 3. So every time we see an X, we're going to plug in 4 root 3. So to find this side, the X, let's plug the X value into there. So X equals 4 root 3. To get the Y value, let's plug in the X right here. And you get 8 root 3. So the side that has the x is 4 root 3. The side that has the y, or the hypotenuse, is 8 root 3. Now go ahead and try this problem, pause the video, and then come back. So we have a 30, 60, 90. So let's label our sides. So the side across the 30-degree angle is x. The side across the 60-degree angle is x root 3. And the side across the 90-degree angle is 2x. Now, in this problem, this part is going to help us solve for the value of x. So 11 equals 2x. So to get the x by itself, you divide both sides by 2. And x equals 11 over 2. So remember, but we're trying to find the measurement of this side and this side. So let's plug in this x value to help us get our answer. So if we plug in the x value here, we know that x equals 11 over 2. So that right there is our missing side. That's half of our answer. Let's find the y value now. So according to what we labeled, x equals x root 3. But if we plug in the x value, you get 11 over 2 times root 3. So the y value is equal to 11 root 3 over 2. Nothing simplifies, so you are done. Let me just label it so you can see what we just did. This was given, this was 11. The x is 11 over 2, and then the y is 11 root 3 over 2. So if you were to try Pythagorean theorem on this, it should work since it's a right triangle. And that's how you can check to see if you did it right. Now, for example 3, it's a little bit of an application problem. Now, an equilateral triangle has a side length of 10 inches. Find the length of the triangle's altitude. So in other words, find the height. So let's draw a picture. We have an equilateral triangle. So an equilateral triangle is a triangle with all equal sides and that has a side length of 10 inches. In other words, this is 10, this is 10, and this is 10. And the question says find the length of the triangle's altitude. So in other words, find the height. Now, the problem said we have an equilateral triangle. So you have to know that an equilateral triangle has equal sides, which you already know, 10, 10, 10. But it also has equal angles. And remember, the addition of the angles in a triangle is 180. If you divide that by 3, you get 60. So each angle is 60 degrees. So this is 60, this is 60. The one at the top gets cut in half by our height. So this right here is 30, and this is 30. So as you can see, we have two 30, 60, 90 degree angles. So let's use the one on the left. And let's solve for our height. First thing I'm going to do is I'm going to redraw the triangle so it won't look too messy. And let's label it. So we're trying to find the height. So this right here. So if I label it based on this right here is 10. Now, one more thing. The base for the whole triangle was 10. So if I took half of that, this right here is going to be 5 units. And of course, important part, let's label our angles. Now let's label our sides. The side across the 30-degree angle is x. The side across the 60, which is what we're trying to find, is x root 3. And the hypotenuse, the one across the 90-degree angle, is 2x. So of course, that's the part that's going to help us solve for x. So 10 equals 2x. If you solve for x, you get x equals 5. So let's plug that in, and then we will be done. Oh, and really, we didn't have to do that since we already knew the value of x right there. But I just did extra work. So to get the height, let's plug the x value in here. And the altitude, or the height, will be 5 root 3. Okay, so let's go to example 4. The altitude of an equilateral triangle is 18 inches. Find the length of a side. So now we're working our way backwards. Now I gave you the I gave you the height, which is 18, and you're trying to find the length of a side. So remember, all the sides are congruent, so we're only trying to find one of the sides. So remember, the equality of an equilateral triangle is that all the angles are congruent. So again, 180 divided by 3 is 60. So this right here is 60 degrees. This is 60 degrees. The one at the top gets cut in half, so we have a 30 and a 30. So we have a 30, 60, 90. I'm going to redraw this triangle here so we can solve the problem. So we have the 90-degree angle, 60's here, 30's there. We're trying to find the hypotenuse, one of the sides. And we also know the height, which is 18. So let's label our picture. The side across the 30-degree angle is X. The side across, let me do that in a different color. The side across the 60-degree angle is X root 3. And the hypotenuse, the side across the 90-degree angle, is 2x. Now, we're looking for this, so we need the value of x, so let's find it. We're going to use this right here to help us solve for the value of x. So x root 3 equals 18. So to solve for x, you divide both sides by square root of 3. X equals 18 over root 3. And of course, you can't leave it like this. You have to rationalize, multiply both numerator and denominator by square root of 3. You get 18 root 3 over 3. And if you reduce, you get 6 root 3. Now, this right here is not the final answer. So all we found so far is the value of x. So all we know right now is that this x is equal to 6 root 3. And if you plug in 6 root 3 here, you should get 18. So we have this side's 18, but we're trying to find this right here, the hypotenuse. So we have the x value, so just plug it in. 2 times x, and then x is 6 root 3. And if you multiply those, you get 12 root 3. So that right there is our final solution. 12 root 3, that's the length of one of the sides of this triangle. The second special right triangle is the 45, 45, 90. So again, this is the new relationships that you have to memorize. So for a 45, 45, 90, you label the triangle the following. Across the 45-degree angle, you label this as x. And since this angle is congruent, the other side across from the 45-degree angle will also be x. So these two will be the same. And the side across the 90-degree angle, you'll label that x root 2. So something you have to memorize. For the 45, 45, 90, you have to memorize the following. X, x, and x root 2. So let's solve the following problem using our 45, 45, 90-degree properties. So find the value of x in each triangle. So let's go ahead and just solve for the value of x and the y. So let's identify what type of triangle we have. So we have I see a 45 and a 90. So of course this has to be 45 degrees. So let's label it according to the picture I just showed you. So across from the 45-degree angle, you have x. Across from the other 45-degree angle, you also have x. So notice that we already have the value of x. And across from the 90-degree angle, we have the x root 2. Now, let's find the value of x and the y. So since we know that the x value is 14, this will also be 14. So we already have two of the legs. So to get the hypotenuse or the y, all you have to do is plug that x value in. So y is equal to x root 2. You just found the x value, which is 14. So the y value is 14 root 2. Let me redraw the triangle. So we just found that this side is 14. Since it's a 45, 45, 90, the other leg is also 14. And then the hypotenuse is 14 root 2, since it is x root 2. So remember, you could have solved this using SOHCAHTOA, but the properties of special right triangles makes it so much easier. Go ahead and try the following problem, pause the video, and then come back. So you have to identify what type of triangle you have. So the only angle I see right here is a 90-degree angle. So remember, degrees in a triangle are 180. So if you take 180, subtract 90, you get 90. These two angles should add up to give you 90. So of course, if you divide by 2, you get 45 for each. So we have a 45, 45, 90. Now, let's label our sides. So across from the 45-degree angle, you have x. Across from the 45-degree angle, you have x. Across from the 90-degree angle, you have x root 2. So of course, this is going to help us solve for the value of x. If you solve for x, you divide both sides by square root of 2. X equals 18 divided by square root of 2. We're not done. You have to rationalize. Reduce. And that's the value of x. So in other words, this was 18, the hypotenuse. The leg was x, so we just found the x, which is 9 root 2. As is it's a 45-degree angle, this is also 9 root 2. And again, if you try Pythagorean theorem with these three, that's how you can check to see if you are correct. For the final problem, we have an application for our 45, 45, 90. Now, the perimeter of a square is 48 meters. Find the length of a diagonal. So let's start by drawing the picture. The perimeter of a square. So let me draw a square. So here's my square. Remember, squares have equal sides. And it says the perimeter is 48. So of course, the 48 divided by 4 equal sides, you get 12. So in other words, this is 12, this is 12, this is 12, and this is 12. So the question is, find the length of a diagonal. In other words, find the length of this right here. Now, you should already know what type of triangle you're dealing with. I see these two sides. Let's use this triangle in pink. So let's use that triangle to solve for the value of x. Now, I see that two sides are congruent, meaning the two angles across from those two sides should be congruent, meaning this is 45. This is 45, this is a corner, so of course this is 90. So we have a 45, 45, 90-degree angle. And if we label it using our properties, across from the 45-degree angle, you have x. Across from the 45-degree angle, you have x. Across from the 90-degree angle, you have x root 2. Notice that you have the value of x, so plug it in and you are done. So that's the hypotenuse or the diagonal for our problem.